This is where things start to be a bit interesting. I like it here. So now we at 1.1.3. We're at 1.3 where we're solving, when you're dealing with inequalities. I think that's where mathematics starts to, get sexy. It starts to become interesting for me, for real, for real. Okay, cool. Let's solve 1.3. It literally says solve for, what did they say? Solve for x if f at x is greater than 0, given that f at x is this quadratic function, or this is a parabola, by the way. Okay, cool. So let's go straight to our notebook. Go straight to our board. It said f at x, 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 f at x equals f at x, f at x equals x squared plus 8x plus 16. Eh? So now they're saying this f at x, that's your 1.3.1. Eh? They're saying if f at x is greater than 0. So they're literally saying x squared. Okay. They're literally saying x squared plus 8x plus 16 should be greater than 0. No? You can literally... Normally what I do here is I'll just determine the critical values. So what are my critical values? I literally say for my critical values, let this thing be equal to 0. So it will be literally x squared. It would literally be what? It will literally be x squared plus 8x plus 16 equals to 0. So when you solve, you're literally looking for points or for values of x for which this function is what is equivalent to 0. Okay, cool. Okay. You can literally look for factors here as we've done before. It should be x, and then factors of 8 then make up, factors of 16, it's 8 times 2. It's also 4 times 4, it's 16 times 1. But which factors make up 8? Because this sign is what? This sign is positive. Ne? So that means your factors have similar signs and they take sign of the middle term. So they are both positive. So you literally have plus and a plus. 4. You need to revise this if you're not comfortable with determining like factors. We did this in the first lecture, so in the first lecture, yeah. Just go back to that lecture and recap. Okay, cool. So that means therefore your x, because this is literally the same thing. You know what I'm saying? This is literally the same thing. So that means now your x is equals minus 4. Okay. But we haven't solved the problem at hand. They said we should determine the values of x for which this function is what? Greater than 0. That's what they're saying. But we know that at x equals to minus 4, our function is equal to 0. So it only has one x-intercept. You should know that when there is a positive sign here, that means your graph is looking like this. But if there was a negative sign, that means our graph is going to look like this. Ne? You know what I'm saying? Okay, cool. Since here there is a positive sign, and what we generally do in inequalities, we always ensure that there is a positive sign here. What do I mean by that? Say there was a negative here. What are we going to do here? We're just going to divide by -1, -1, -1, -1. And our inequality sign was going to change to, if you divide by negative, your inequality sign flips. It changes it changes the direction. And also, you just need to make sure that there is always a positive here. Ne? So it's easy to use the method that I'm just going to outline now. Okay, cool. So let's draw our function. Then maybe let's just erase what I was saying, because it's not that relevant to the problem at hand. Okay, cool. So our function then looks like this. It looks like this. If you were to draw it at -4, you know that my graph has a point here at -4. There is a point here at -4, right? That's what we know about the function. And it's facing what? It's facing upwards. The only way this graph can only have one x-intercept is if and only if it has a turning point at -4. That's the only way. So this is how our function looks like. So what can you then say about this function? It's positive. When you go this direction, it's positive. You see our function is just positive. It's heading upwards. Ne? It's literally doing what? Heading upwards when you're going this direction. Also, when you're going this x direction, it's heading upwards. So what does that tell you about this? This is f at x. Ne? This function is literally your f at x. Ne? In generic term, this is your f at x. Ne? This is your f at x. What does that tell you about the okay cool let's just try and zoom it like this. Yeah, what does that tell you about the solution of the problem at hand? It literally says to you the function can only be positive when x is greater than -4, right? When you're heading this direction. When you're heading what? This direction. Eh? And also, you should know that it's also greater than 0 and x is less than what? X is less than what? -4. But you know that x is an element of what? X is an element of real numbers. Ne? X is an element of real numbers. So my handwriting is a bit cute. So you guys should, yeah. X is an element of real numbers, but x should either be less than -4 or x should either be greater than what? But then -4. That's relatively simpler. If it's not clear, yeah, you can always reach out to us, info@destination-varsity. Then you'll get more one-on-one sessions where we explain these things like in depth. Okay, cool. Let's go to the second problem. Not second problem to say, but I think it's 1.3.1. Let's go to 1.3.2. 1.3.2. 1.3.2 is saying solve for x for cool. It says for each values of p, will f at x equals to p have two unequal roots? Okay, let's just delete this because it's no longer relevant. I mean, we don't wanna start a new page when we can just delete this. Delete. Yeah, that's the most interesting thing here I was looking forward to. 1.3.2. It's very, very interesting. And it's simple, but it's interesting. You know, I like interesting things. What is it saying? It says for each values of p, will f at x equals to p have two unequal negative roots? What does that tell you? When they say two unequal negative roots, okay, let's go back to the let's just write down the problem. It says that's 1.3.2, ne? So it says f at x equals p. This has what? Two unequal negative what? Negative roots, ne? Okay, cool. So there are two parameters that you need to be mindful of in this problem. It says your roots are unequal, ne? But they should be real. Like they should be real, ne? So for roots to be real, you know that if they're unequal, the discriminant should be greater than 0. They should be real and unequal, so the discriminant should be less than 0. What is a discriminant? A discriminant You know, in the quadratic function, in the quadratic equation, the one that says x equals minus b plus or minus square root of b squared minus 4ac, 4ac all over 2a. So this guy over here, okay, let me just zoom out so you all can see. So this guy over here, the one that is under the square root, is regarded as the discriminant. Ne? So that's your discriminant. Ne? So when they say the roots are unequal, your discriminant should be what? Should be greater than 0. Okay, let's rearrange our problem nicely so we can determine the discriminant. Ne? Oh, we forgot to delete this. Let's delete, and delete again. Okay, cool. So we have our function is f at x. Instead of f at x, we can just write x squared plus 8x plus 16, and they said this is equal to p. Ne? Let's rearrange this in such a way that it becomes a quadratic-ish. When I say quadratic-ish, yeah, it should be a quadratic in a quadratic format. Ne? So you can drop this down here. 8x plus 16 minus p equals 0. You know, this is in a form of ax squared plus bx plus c. So this guy over here is your c, and this is your b, and this is sorry, your 1 here. There's always the 1 here is your a. So your a is 1, your b is what? 8, your c is what? 16 minus p. Yeah, let's then solve for the problem at hand. If we were to determine a discriminant of this, you know that this discriminant should be what? Should be greater than 0. For this thing to be what? To have real roots that are unequal. So now that means since your discriminant formula, as we said here, it's this guy over here, it's this part over here. So it should be b squared. What is b here? Your b is 8. So it should be 8 squared minus 4. A is 1. C is what? C is 16 minus what? Minus p. And that should be greater than 0. No? That's what it's saying. Your 8 squared, what's your x squared? Is it 64? What is x squared? Yes, 64. So it's 64 minus, because this 4 times 1 is 4. So minus 4 times minus 16. What is 4 times minus 16? 4 times 16. That's also 64. Minus 64. No? Then minus 4 times minus p, it's plus 4p. No? Greater than 0. What are you noticing here? Here you should notice that your 64 and minus 64 are cancelling each other, right? That's what the math is telling us. These guys over here, they cancel each other. So to create some space, let's rather shift this. Okay, let's rather shift to this side. Let's take our problem to this side. So now you have 4p. Okay, let's resort to our black again. 4p is greater than 0. 4p is greater than 0. You can divide by 4 here. Therefore, your p should be greater than 0. Are you done solving the problem at hand? No, you're not done. Why? Because you just solved for the part which says the roots are real and unequal. How do you ensure that they are negative now? You know, it's simple. It's so simple. How do you determine the roots? What are roots? That's the question you should be asking yourself. Roots are x-intercepts, like the x values. So you determine them using this equation over here. You know what I'm saying? So it should be simple, but now they just complicated it by saying they should be unequal, they should be negative. You just need to know that your discriminant for them to be unequal should be greater than 0, And for them to be real, it should be greater than 0, unequal, yeah, something like that. It should not be equal to 0 for them to be unequal. For them to be real, it should be greater than 0. And then now they are saying they should also be negative. So they are saying this part, when you're determining your x values, they should be negative. And that's mostly dependent on the numerator, given that our a is positive, right? So let's go back and correct for that factor, which says our root should be negative. Let's shift to this side again. So we create space for ourselves. So x is equals minus b plus or minus square root of b squared minus 4ac all over 2a. Ne? Let's resort to black again. Your b, what was the value of b? Was 8. Ne? Minus into 8 plus or minus square root of 8 squared minus 4. Your a was 1. What was your c? It was 16 what? 16 minus what? Minus 2, ne? Okay, that's 16 minus 2. 16 minus... Sorry, minus p, apologies. 16 minus p. Okay, 16 minus p. 16 minus p. All over 2a. Oh, sorry, your a is 1, right? All over 2a. Okay. So, I mean, you can't do the same thing twice. You determine that this thing, like the discriminant, so the thing that's under the square root boils down to what? To 4p. You can literally write this thing like this. Okay, maybe let's put a line here to ensure that you don't cross this guy over here. So we segregate our working. So that means you can literally say x is equal to minus 8 plus or minus square root of 4p, né? All over 2. Now, there's one thing that you need to note here. For this thing to be negative, this guy over here, this part, for this thing to be negative, it should be what? It should be less than this one. So that means for this x value to be negative, your minus 8 should be less than what? Oh, sorry, should be greater than what? The square root of 4p, né? Right? Your minus 8 should be greater than what? The square root of what? Of 4p. For this thing too, because when the square root of 4p is greater than minus 8, that means the answer positive, the answer in the numerator will be positive, right? So your minus 8 should be what? Greater than what? Than 4p. Okay, cool. So now, for what values of p is this thing realistic? When you say minus 8 should be greater than what? Than 4p. Let's just eliminate the square root sign. Let's just eliminate the square root sign before we solve for p. So you adding squared. So it'll be 64 equals, less than 4p, né? Then you divide by 4 again, right? So let's literally say 64 divided by 4. Therefore, p should be less than, or let's just keep it like this, né? P should be what? Less than 16. Or you can write it like this if you want to. P should be what? Less than 16. So how do you then write your final answer? Because now, firstly, you started by saying your P should be what? Greater than 0. So that means your P should be between what? Your P should be less than 16, but what? But greater than 0. That was the most simplest mathematical problem we've ever solved. So this is how you generally approach these things. But for you to get the hang, you need to do as many problems as you possibly can. If you get stuck somewhere, email info@destinationvarsity.com. We'll gladly assist you because the objective is to ensure that you get 100%. When we return, we'll just head straight to the next section, which is more about, I think it's number patterns, if I'm not mistaken. But yeah, I think it's number patterns because we're done with question one. Danko!